more than 30 years of research, Dr. Tivadar Babó, the internationally recognized viticulturist, has discovered a revolutionary new method for the mechanized yield and quality regulation of grapes. The prominent expert has studied the biological characteristics of grapes literally for decades, and based on his careful observations has created his method. Through his new method, the quality grape production significantly simplifies. Also, a lot less manual work is required, and the cost of production is greatly reduced. By applying his technology, the money invested in grape production returns much quicker. This traditional hand pruning technology has been practiced for almost 3,000 years. These pictures depict grapes that are being cultivated by hand pruning, the old traditional method of grape growing that requires labor-intensive and expensive procedures. It is a never-ending game between man and the vine stock. Each year we prune the vine so that in the next year its new shoots will grow even longer. So the vine stock is forced to spend 50% of its biological energy on nurturing its new shoots, which we throw away at the end of each year. For reproduction, that is nurturing its fruit, only 50% of its energy remains. The traditional stock forms must be cut each year, and a great quantity of new shoots must be discarded. This losses the price for growing better quality fruit. Following pruning, the vine grows even longer shoots. The new technology minimizes this procedure, requiring a lot of manual work. How can we achieve that the tremendous energy used for growing shoots be effectively redirected into growing better quality fruit? Furthermore, with mechanization, the high quality of the crop also be ensured. The patent of Tivadar Babó has found the answer to this question. The new branch cordon technology can be used on the traditional 6 to 7 feet tall trellis. The transfer does not require any additional investment. The required result can also be achieved by converting a traditionally cultivated plantation. How can this system be introduced? Over the tops of the poles, we should pull a wire holding the cordon arm straight. The branches in the row are continuously touching each other. In the year before the vine turns to bearing the new shoots, prior to bud break, they must be thinned out in approximately 10-inch intervals. The remaining canes shall be tied to the drip line. As a result of the new process, the canes of the vine are trained to bend downwards and ultimately remain on the vine stock. Thus the plant need not renew the majority of its vegetation surface each year. This is not the traditional vegetative state inducing long shoot growing. The plant with increased production surface reaches a generative, that is, producing state. With the traditional technology, generally long shoots are growing from 10 to 40 buds. With the branch cordon technology, the growth energy divides among approximately 150 to 200 shoots, so the shoots remain short. These shoots will ripen in a self-regulated way after the vintage. After transformation of the plantation to the branch cordon technology, these shoots rarely need to be cut during winter. The quality of production can be regulated with the application of a patented, very economical machinery, developed specifically for this purpose. In the upper zone of the leaf wall, we are thinning out or brushing off the developing buds of the vine. The shoots from the secondary buds increase the leaf surface. By setting the width of the zone where the main buds are removed, we can set the desirable cluster leaf proportion. Thus the quality and quantity of the production can be regulated with certainty right at the beginning of the yearly cycle. The essence of the invention is that the portion of the grapevine's energy that until now produced new shoots was redirected to increase quality and yield. In the traditional technology, the bottom part of the trellis is not utilized for vegetation purposes. The new technology utilizes the total height of the trellis. By increasing the assimilating leaf surface, the proportion between clusters and leaves also grows. As a result, the number of clusters can significantly be increased together with the quality. We do not know any other viticulture technology which ensures an end product of the highest quality with a growing production yield. This will create an ideal production wall that is not thick at all, so the leaves and clusters are exposed to the sun. The neighboring rows keep the clusters zone in partial shade. Therefore, the sun does not burn out the acid content of the grape. The resulting wall provides shade for the soil that protects moisture underneath and prevents weed formation. The majority of the production is in the lower section of the plant, where a ramifying shoot system develops, which, forming a well-arranged production zone, is laden with grapes. The new technology promotes the ripening of the clusters and shoots. The new technology creates the following positive changes. Pruning is limited to a minimum. Shoots and canes becoming significantly thinner than the pruned grapes, increased resistance to winter frost, hail and wind. The frost sensitivity in spring is lower because the number of buds is much higher. Leaf cover starts to form early in the growing period. The plant begins to assimilate by its whole leaf surface from May on. In summer, the work demand also significantly falls. Damage caused by fungi, moths and mites becomes less, therefore pesticide spraying significantly decreases. Under the canopy of the leaf surface, the acids do not burn out. Vines will become increasingly stronger and consequently more resistant. The regulation of quantity and quality is totally mechanized in a unique way.
This is the future of a new technology of pruning on this kind of variety here. We have more tons and better quality than any other varietal or any other trellis system. I again agree very much that this is the future for later on to come.
Vine production worldwide is in crisis. Producers who can achieve the better quality at